All right, on a new page in your spiral notebook, we're going to title this Solving Systems of Equations. And our next method for solving is going to be using substitution. Now, substitution is the first of our algebraic approaches, okay, to solving a system. So the first way we've learned it is to solve by graphing, where we find the intersection. Well, this is going to be using an algebraic approach to figure out where the intersection is. So let's go ahead and go into our first example and see how this works. So we're going to solve the system 2x plus 5y is equal to -5, and x plus 3y is equal to 3. All right, and so what I'm going to do for this first one, especially just to hopefully refresh your memory on how this works, we're going to write out a few steps, okay? So step number one, what you're going to do is you're going to solve for a variable. Now you can solve for any variable you want, whether it's the x or the y in the first equation or the x or the y in the second equation. So we are going to solve for one variable, which means we have a choice. Okay, I can solve for this x, I could solve for this y, I could solve for this x, okay, or I could solve for this y. Now, since we have a choice, we want to pick the best choice. So here's my advice. You need to choose the easiest variable. And the easiest variable is going to be the one that has a coefficient of 1. What that means is you don't see the number in front because the coefficient is 1. And so when you put it that way, there's one variable that stands out to me that's going to be the easiest to solve for, and it's going to be that x right there, okay? So let's go ahead and bring down this equation. X plus 3y equals 3. All right, and what's nice about solving for this x is only one simple step right here. We minus 3y from both sides, and I'm just going to write this as 3 minus 3y. I don't necessarily care the order. If you want to put negative 3y plus 3, that's fine too. But with one simple step, I get the x by itself. The other nice thing is I don't have to divide by anything, which means no fractions. Okay, so let's go ahead here and move on to step 2. So step 2, what you're going to do is you're going to substitute x equals 3 minus 3y into the other equation. And it's really important here that you use both of the equations when solving for x and y. And so the other equation is 2x plus 5y equals -5. Okay? Now right here we substituted in step 1 and said that x equals 3 minus 3y. Well, what I'm going to do is I'm going to take that 3 minus 3y and we're going to substitute that in for x. And so it's going to look like this. We're going to take out the x and replace it with what x equals 3 minus 3y. And then we just copy down the rest of the equation. So I know that I'm on the right track because when I look at this, I now have an equation that has all the same variable, which means we're going to go ahead and solve for y. So let's distribute. 2 times 3 is 6. 2 times 3y is 6y. Copy the rest down. Okay. Now before I do anything else, I see that I have 2 y's on this side. So I'm going to leave the 6 out front, but I'm going to condense the -6y. Okay. And I'm going to take the 5y and we're going to combine like terms to make that -1y. And that equals -5. And so now we can go ahead and minus 6 from both sides and we get -1y equals -11. Divide both sides by -1 and we finally come up with our first variable, y equals 11. All right, so that leads us to our third and final step is to plug in y equals 11 to find x. Okay, now I left that a little bit vague when I said plug in y equals 11 because I'm going to scroll back up to the top here and I want you to look at the original equations. Okay, so we've got a couple choices. We could plug in y equals 11 into this first equation. which works, but it's not the easiest. We could plug y equals 11 into the second equation, but it's not the easiest. The best place to plug it in is going to be this right here, this equation from step 1 where we solved for x. And so if I write this down, x equals 3 minus 3y, then all we have to do is plug the 11 in for y. Okay, 3 minus 3, take out the y and replace it with an 11. Now this is where you can either get your calculator or we can keep going, doing mental math. 3 times 11 is 33, but 3 minus 33 is going to be negative 30. And so we have just now found the value of x and y. Now, quick reminder, when we write the solution to a system of equations, we represent that solution as the ordered pair negative 30, 11, where it's always assumed that the x coordinate comes first and the y coordinate comes second. Okay, so what we just did was figured out the intersection of the two lines. We just did it through algebra rather than having to graph it. All right, so let's look at another type of equation. All right, for example 2, we are going to solve this system. 12x minus 3y is equal to negative 9, and negative 4x plus y is equal to 3. So go ahead and hit pause if you need to copy this down. And let's work through this, but I'm still gonna write out a few steps, but I'm not gonna put it in words, so it'll go a little bit quicker. Step 1, here's your entry point. You need to figure out a variable to solve for. We need to pick the easiest variable. Well, the variable that catches my eye is the one that does not have a number in front, which is this y right here. And that is going to be the easiest variable to solve for. So I'm going to copy down this equation, negative 4x plus y equals 3. And with one quick simple step, we can get the y by itself. All right, so by picking a variable with no number in front, you're not going to have to divide, which means no fractions. I'm going to box this in because first, this is what I'm going to substitute in for y in step 2. And also, I'm going to come back to this at the end, and I'm going to plug in, I'm going to use this equation to figure out what y equals. All right, so step 2 is now we're going to use the other equation, and we're going to replace the y with this, what I boxed in, 4x plus 3. All right, so 12x minus 3, we're going to take out the y and replace it with 4x plus 3. And then we write the rest of the equation, and that equals negative 9, okay? You know you're doing this right when you now have an equation that has just one single variable, and that is we're solving for x. So 12x, 3 times 4x is minus 12x, negative 3 times 3 is negative 9, and that equals negative 9, okay? So what I notice here when I go to combine like terms, I have a 12x and a negative 12x, and what's going to happen right here is it cancels out to make 0x. And we're left with negative 9 equals negative 9, all right, which we've had happen before when we solve equations. And this is going to be one of your special solutions right here. Since this is true, this means that there are infinite solutions. Visually, this means that the two lines that were given in the original problem are the same line, and they intersect at every single point infinitely. Okay, so that is what it looks like algebraically to have one of your special systems. Down the road, if you were solving a no solution, what would happen is you would get your variables to cancel out, but you would be left with a false statement. And if it's false, that's when we would say that it is no solution, okay? Just keep that in mind for down the road. Now, the last thing that we're gonna do, the last couple of examples, let's take this concept of using substitution and let's do a couple different application problems. All right, so we're gonna find the value of A so that the system has infinite solutions. Kind of extend on this idea from example 2. And so the system is going to be 3x plus 9y equals A, and x plus 3y is equal to 6. Okay? So I think the hardest thing with these is we look at it and we just get stuck on that A and we're tempted to say, I don't know what the A value is, but you got to get past that. We have to kind of ignore the A, pretend like it's not there, and let's go in and start substitution like we always do. Pick a variable, okay, either X or Y, that's the easiest to solve for. And the one that stands out to me is going to be this X right here because it has a coefficient of 1. And so what we're going to do here is let's go ahead and take this equation, and with one quick step, we now have X by itself, okay? And we're going to substitute this 6 minus 3y into the other equation. So here's the other equation, right? And what we're going to do is we're going to take the 6 minus 3y and we're going to substitute that into X. So 3, replace the X with 6 minus 3y plus 9y is equal to A. And again, we keep solving. We're not worried about the A right now, okay? You're not going to know the A until you're at the very end of the problem. And so I'm going to distribute the 3, and we get 18 minus 9y plus 9y is equal to A. All right? Now, like what happened before, when I go to combine like terms, what do we notice happens when you have negative 9y plus 9y? Well, the y's are going to cancel out, and what we're left with is 18 is equal to A. Well, if this system is going to have infinite solutions, then we need the result to be 18 equals 18, which means the A value is going to need to equal 18. Okay, so I hope you can see here that we really are just doing substitution and we come up with what that A value is at the end. All right, so we'll try a couple more of those in class. Here's the last problem, the last kind of application that we're going to see. Okay, the sum of two numbers is 6. Okay, the first number is 33 less than twice the second number. Okay, you can hit pause if you need to, but go ahead and finish writing this down. All right, and when you're ready, this time we're gonna set up a system of equations to solve this problem. All right. Well, the first thing I like to do is I like to kind of define what my variables are. And so what if we just go ahead and call X the first number, and then we let Y go ahead and represent the second number. So then as I'm reading the problem, when I start reading things like the first number is or the second number, we can replace that with X and Y. My first equation right here is going to come from this first sentence. If we reread this, the sum of the two numbers is 6. And so the equation is going to be the sum means addition. The first number plus the second number is equal to 6. Okay? But you can't solve just one equation with an X and a Y. We're going to need a second equation. And that is where we're going to reread this part. Okay? The first number is 33 less than twice the second number. And so the second equation, okay, again, it says the first number is. This is right here represents the equal sign. So X equals. Now this part's always a little tricky. 33 less than twice the second number. It's the 33 right here that's being subtracted, so we need to write twice the second number and then take away 33. And what we have is a system of equations that we have just written based on that information. Well, the way that this problem is set up is this is a perfect substitution problem, right? We already have X solved for right here when we have X equals 2y minus 33. So let's rewrite the second equation. X plus y equals 6, and let's replace the X, okay, right here with what X equals, which is going to be 2y minus 33. And then we just write the rest of the equation, plus y equals 6. All right, so really the algebra on this is pretty simple. It just took a little bit of work getting that set up. All right, basically there was a 1 in front. I distributed a 1, nothing changed. When I combine like terms, a 2y and a positive y is going to make 3y minus 33 equals 6. So let's keep solving. Let's add 33 to both sides. 3y is equal to 39. And then we take 39 divided by 3. And we get our first variable, which is 13. All right? Well, now we need to plug the 13. And this, by the way, this is the second number. Well, let's plug it back in and figure this out. Well, the easiest place to plug it back in is going to be into this first equation. Remember, the sum of the numbers was 6. Well, if we replace the y with 13, we can then solve for x by subtracting 13 to both sides. And 6 minus 13 is going to be negative 7. And this right here is going to be the first number. So then finally, to answer the question when it says find the numbers, okay, are going to be negative 7 and 13. And in this case, we don't need to write that as an ordered pair because you're not necessarily figuring out like the intersection per se, you're trying to figure out the two unknown numbers. All right, that's it for now. I hope that helps, and we will continue